Yeah, so hello everyone. Welcome to this stream where we will talk about how to run your own full Bitcoin node on Linux. And I will first run through the agenda for today. So I will talk a little bit about me and about the book itself, Grokking Bitcoin. And then we will start to talk about Bitcoin full nodes, what they are useful for, and why you might need them. And then we will go through step by step to how to set up a Bitcoin full node and actually do it on the Linux command line, get our hands dirty. So that's what we're gonna do today. So let's talk a little bit about me. I'm Cli Help. I am a software developer since 20 years or so. And I started my Bitcoin journey in 2013 and 2015. I started my own consultancy firm, Propeller, where we do Bitcoin related development for various customers. And I was contacted by Manning in 2016, and they asked me if I wanted to write a book about Bitcoin, and I said, sure, let's do it. So that's the backstory. And you can reach out to me. I'm available on Twitter. My handle there is Cli Help. And on Mastodon, which is an open source version of Twitter, so to speak, it's at kalle@bitcoinhackers.org. And if you're into PGP stuff, you can. I have written my PGP fingerprint right there as well. So that's it about me, I think. And now a little bit about the book itself. So the book is Grokking Bitcoin. It's a technical deep dive into Bitcoin. And you can get it from Manning's website and all other major bookstores. If you get it from Manning, you can use the code TWITROSE40 to get 40% off when you purchase it. So check that out. So it's available on Manning's website, manning.com. And I will show you a little bit from the book. I will browse through a few things in the book to give you an idea of what the book looks like, what you can expect from it. So first of all, it's a technical book. It's not primarily for developers. It's for technically interested people wanting to understand Bitcoin on a deeper level, how the protocol works. And you might want that for several reasons. But whatever the reason, if you're a technical person, please check it out. I think you'll like it. And to give you an idea of the learning path of this book, I will walk you through a few chapters. First of all, chapter 1 is about Bitcoin. That gives you the big picture, why Bitcoin matters, why, what problems it solves, and how it operates on a very high level. And then chapter 2 sets you off on a journey where we will build Bitcoin from scratch. Bitcoin is pretty hard, so in order to understand Bitcoin, you need some way to approach it. And I chose to use a very simple starting point and build Bitcoin from there. So the journey starts off here with a so-called cookie token spreadsheet. I invented a very simple, very stupid money system that's called cookie tokens. It's highly centralized and very unsecure. It's controlled by a central authority named Lisa, and she manages this online spreadsheet that keeps track of everybody's money. And that's not very secure, of course. But that's a very simple starting point that everybody can understand. And from there on, we add Bitcoin technology chapter by chapter until we end up with Bitcoin in chapter 8. So for example, here in chapter 2, we start with adding something called cryptographic hashes. And we do that through illustrations and very concrete examples. So chapter 2 adds cryptographic hashes, digital signatures, and chapter 3 addresses wallets, transactions, and the blockchain, proof of work, and in chapter 8 we end up with the peer-to-peer network, which is the final piece of the Bitcoin puzzle. So when we have added the peer-to-peer network, we have actually ended up with Bitcoin itself. And then we have 3 more chapters that goes a little bit deeper into certain topics. And also in chapter 8, there is a tutorial on how to run your own full node. This is what we're going to do today, basically, with minor changes. So we're going to run through this tutorial, and also we're going to run through parts of Appendix A, where we continue where we left off in chapter 8. After we set up our own full node, we will create a wallet in Appendix A and send money to it and send money from it. So that's the goal of today. Okay, so let's go back to the presentation and talk a little bit about Bitcoin full nodes. So there are different ways to use Bitcoin which gives you different levels of self-sovereignty, if you will. You can use something called web wallets. A web wallet is basically a website where you log in with a username and password. And that website will show you your balance, and if you send Bitcoin to it, its balance will increase, hopefully. But there's a problem with web wallets, and that is you don't control anything about Bitcoin here. Somebody else is controlling your Bitcoin private keys, the keys that are needed to spend your Bitcoins. And they also control all the information. So they might lie to you about Bitcoin's monetary, or they might lie to you about your financials, and they might lie about other people's financials, and they might steal your money because they can control they control your Bitcoins. So I don't recommend anyone to use web wallets. And then you have something called lightweight wallets, which are a bit better. With lightweight wallets, you control your own keys that are needed to spend your own Bitcoins. So no one else can steal your money, but as long as your keys are safe on your own wallet, your money is safe. And most mobile wallets fall into this category. So the vast majority of all mobile wallets are lightweight wallets like this. So with lightweight wallets, you control your own keys, but you don't control the information. Lightweight wallets still depend on servers on the internet to one moment, I need to check the audio here. Yeah. Sorry. So lightweight wallets depend on servers on the internet to provide them with information about transactions. And those servers can lie to you. They can hide information from you, or they can give you fake transactions. So you might believe that you have more money than you actually have, or you might believe that you haven't received money that you have received, and so forth. but they can't really steal your money. And then you have the full node level, which is the sort of nirvana of Bitcoin usage. With full nodes, if you run your own full node, you verify all transactions in the Bitcoin network. And we'll go through what exactly a full node will give you. But with a full node, you control your own keys and you control the data. You control the financial information. So no one can hide information from you. Okay, so let's see now what's in a box. What's in the box when you install a full node? Or what do you get from it? Well, you get a piece of software that verifies every aspect of Bitcoin. It will verify all the transactions, your own transactions and everybody else's transactions, and it will also verify all the rules in the Bitcoin protocol. So, for example, it will verify that no one creates more Bitcoin than the predetermined rate of issuance of new Bitcoins. And it's censorship resistant. It means that no one can stop you from sending transactions or receiving transactions, or anyone else from sending or receiving transactions. And it's more private than the other options, because a Bitcoin full node will subscribe to all data in the Bitcoin network. And when you query for your transactions, you want to check the balance of an address, for example, you query your own full node for that information. And because that full node has received all the information from the Bitcoin network, no one will see what you query, because you only query your own node. So all the data is contained there, and you don't have to query some third-party servers to get you the information you need. And you also have a built-in wallet in a full node. Actually, you can have multiple wallets concurrently in a single full node. A full node will also provide you with infrastructure for lightweight wallets. As I said before, lightweight wallets queries servers on the internet to get the information it needs. But if you can configure some lightweight wallets to connect to your own full node, and that means that you get the best of both worlds. You get the mobility of a lightweight wallet in your phone, but with the security of a full node, because the lightweight wallet uses your full node to get information so that it can't be lied to, which is nice. And you get a nice graphical user interface. We will not use that today, but it's there and it's nice, it's very easy to use. But instead, and also you get a clunky but quite versatile command line interface. And this is what we're going to use today. And also, you can invite your friends and family to use your full node so that they don't have to use random nodes on the internet. It's better for your little brother to trust your node instead of trusting random dudes on the internet. So that's a good deal, I think. Everybody doesn't have the skills necessary to actually run a full node and understand the implications of it. Okay, so we are approaching the tutorial, and we are going to use a piece of software called Bitcoin Core, which is the reference implementation of the Bitcoin protocol. Virtually everybody uses this for full node. It's the go-to implementation. And we will use the command line on Linux to do it. And one more thing, Signet. We are using Signet, which is an alternative network, which is fake Bitcoin. Signet is like it's like Bitcoin, but it's another network, and the money is fake. So it's you're managing fake money, fake Bitcoin, and we call this network Signet. And it's a new feature of Bitcoin Core, so it will be available in version 0.21, and that's not released yet. So we will use a pre-release or a release candidate in order to use Signet. And the way we're going to run the full node is probably one of the most hard ways to do it. But I think we're doing it for good reasons, because doing it this way will give you a better understanding on what's going on under the hood. If you run just the graphical user interface, it gives you it doesn't give you as much understanding. So I think this is a good thing to do for training and also fun. Okay. So let's go back to the book and chapter 8. And here we are running your own full node. This is what we're going to do today. We're going to start here. And for people who just joined, I can tell you that we're starting a tutorial on how to run your own Bitcoin node on Linux. And I'm the author of Grokking Bitcoin, which you can get from Manning's website. If you want to get 40% off in checkout, you can use the code TWITROSE40. There you go. I just wrote it somewhere there. TWITROSE40. Use TWITROSE40 to get 40% off. So go to manning.com and get the book. And I will go back to the book. So, to run your own full node, we are going to do a few things. In this first part of the tutorial, we'll make sure that the node is up and running on our Linux machine. And then in the next part, we will actually create a wallet on it and send money to and from it. But now, right now, the goal is to get a full node up and running. And that requires 4 steps. We will download Bitcoin Core. We will verify the software, the integrity of the software, so that we don't download malware or anything else. We will unpack and start the software, and then we will wait for the initial blockchain download to finish. The initial blockchain download is when the node starts from scratch, it needs to sync with all the other nodes on the Bitcoin network in order to get up to date with the recent blocks. Okay, so I will bring up a command line there. So, sorry, there you go. So step 1 is to download Bitcoin Core. And you download Bitcoin Core from Bitcoin Core's webpage, which is here. So this is the main download page. It's bitcoin.core, bitcoincore.org-en-download. Or you can just go to bitcoincore.org. Oh, sorry. bitcoincore.org and hit download button here. And you would normally hit this download button here to get the software you need. But today we are going to use Signet, so that's a little bit different here. We are not going to download this one because this version doesn't have Signet yet. So we're going to use a release candidate, and those are available on /bin under bitcoincore.org. So let's go there. And I'm gonna go for the latest release candidate, which is release candidate 3. And here they have all the downloadables. As you can see, there are several. We are running Linux, and we are running Linux on a 64-bit machine. So that means that we will use this one. And I'll copy that address. And I am now in my home directory, which is rather empty. I just have a temp directory here. So I will wget it like this. And while this downloads, I will show you the next steps that we'll do. So we download Bitcoin Core. That's ongoing right now. And then we will verify the software. And that includes a number of steps. We will not do all the steps, but because of time limitations, and I think we will break the flow of this tutorial if we go too deep into how to actually create your own PGP keys and stuff. But we will download the signature and we will verify the hash. Okay, no, one step at a time. We will download the signature. Because Bitcoin Core signs all their software with all their releases are signed with the Bitcoin Core signing key. And we want to download that signature in order to verify the authenticity of this file we just downloaded. So to get the signature, you go back to where you downloaded the program. We downloaded this one, and this here, SHA-256sums.asc, is the actual is the signature file. So we will download that too. Copy link address. So we downloaded that too. So right now we have in our home directory, we have two files. We have a tar.gz file and a SHA-256sums file. Okay, so we have downloaded the signature file. And then it says we need to verify that the hash of the tar.gz file matches the hash in the message part of the signature file. We'll just scroll down a bit here. We have downloaded this SHA-256sums file. We'll have a look into it. It looks like this. The first part of the file is a statement from Bitcoin Core developers. They say that the cryptographic hash of this file is this. And they say that the cryptographic hash of this file is this, and so on, for all the downloadable files they had. And then they take this whole message here, and they sign it, and they put the signature here at the bottom of the file. So we have a message and a signature in the same file here. And what we're going to do now is that we're going to verify that the program that we downloaded, this file up here, we're going to verify that this program has the same hash as the one that's stated in this file here. And we do that, you can do it in two ways, but I'll do it in the most straightforward way. I'll SHA-256sum it. SHA-256sum is a program that's available on almost all Linux machines from the get-go. Okay, so now it's calculated the cryptographic hash, the SHA-256 of this Linux, of this program here. And as you can see, the hash that we have here matches the hash that we have here. Which means that, okay, the program we downloaded is the same hash as stated in this signature file. But we still cannot trust this because we haven't verified the actual signature yet. Because these statements can be made by anyone, and they can lie about, they can trick us to download a malware version of the program and actually add their malware version hash here, and of course we will get the same hash here when we hash the malware version. So in order to verify that this is not a malware program, we will verify the hash, verify the signature that with the public key of the Bitcoin Core team. And this is where I will skip a little bit. I haven't shown you how I downloaded the key of the public key of the Bitcoin Core signing key, and I didn't show you how I signed that key with my own private key, because that would break the flow, I think. Okay, so we will now verify with a program called GPG, like this. So we'll verify the signature of this file, and it will say like this: signature made December 11th. It's a good signature from this key, and with the word full here, which means I fully trust this key because I have already verified that this key is legit. So now I have verified that the program I just downloaded is legit, that it's not tampered with in any way. So this is the same file as the file that the Bitcoin Core signing team, the Bitcoin Core team signed with. Okay, so we have verified the software. Great. It's next step is to actually unpack and start. Unpacking is just a matter of untarring it. So like this. I haven't mentioned this before, but this tutorial kind of assumes that you have some familiarity with the Linux command line. So I will not teach you anything about the command line itself. I will only teach you about the Bitcoin Core specific commands here. So stuff like tar should be pretty, yeah, you should know about them beforehand. Okay, so I have unpacked it here and it created a directory for me. I will go into that directory, and under that directory I will go into bin and have a look there. I'll start over here. So as you can see, you have a few programs in here, and the programs that we are concerned with today are the first two. It's this one, Bitcoin D, which is actually the full node program that runs the full node. And then we have this program, Bitcoin-CLI, which is a client program that talks to your full node, sends commands to it to create wallets, for example, or stop the full node. So we're going to use this Bitcoin-CLI a lot today, and this too. And I will also mention that this Bitcoin Qt is the graphical user interface version of the full node. So if you just want to run a full node with a graphical user interface, just run this Bitcoin Qt and you're good to go. But if you want to run this program in the background on a server in your basement, you don't need or want a graphical user interface. So that's when you want to use this Bitcoin-D. So we have unpacked the software, and it's time to start it. So I will run this Bitcoin-D program, and I will start it in the background. So I will add the flag daemon, which means run this software in the background, because we want to use this terminal for other stuff than this full node. And as I mentioned before, we are going to use Signet for this, which is the fake Bitcoin network with fake Bitcoin. It is a real network though, but it only contains fake Bitcoins, worthless Bitcoins that you can be less careful with. So we're gonna add this flag Signet, which signals to Bitcoin-D that it should use Signet instead of real Bitcoins, which is called mainnet. So we are using Signet here. Oh, sorry. There you go. Daemon. So it says Bitcoin Core starting. Nice. This means that Bitcoin Core is starting, and we can watch the. Now we can use Bitcoin-CLI on Signet and ask the node for information. For example, get blockchain info, and we'll type it to less because it's quite verbose. So you can see here we are on chain Signet, and we have downloaded a lot of headers already, 16,000. I think that's all the headers there are. These are block headers. So there are 16,000 blocks in this blockchain. And we have so far downloaded 3,748 blocks in this blockchain, which means that we haven't reached the tip of the blockchain yet, but we are approaching it quite fast here. And as you can see here, initial block download is true, which means that we are still trying to sync up with the rest of the network. When we have reached the tip of the blockchain, this will turn into false here. Maybe that has already happened. I don't know. Let's have a look. Yeah. So I ran get blockchain info again, and now we can see that we have all the blocks, and it has turned initial block download is now false. Cool. So we have our Bitcoin Core node up and running, it seems. There's one more thing I want to do before we leave this part of the tutorial. I also want to mention first that if you have questions, you can just put them in the chat. I will keep an eye on it. I will try to remember to watch the chat. So we have now started our node, and I will show you how to stop the node. That's simple. You do it like this. You use the stop command like this, and now the Bitcoin Core node is stopping. And I think also that it's quite tedious to add this Signet, the Signet flag to every single command. So I'm going to create a configuration file for Bitcoin Core that it will read when it starts, and that Bitcoin-CLI will also use when it starts. And I'm just going to do it. Signet to so I'm adding a line to a file called bitcoin.conf. Actually, that's the only line in that file right now. And this means that by default, when you start in Signet mode. So right now we can start Bitcoin Core like this. Same error again. Happens all the time. So Bitcoin Core is starting, and we can check the blockchain info. So Bitcoin-CLI, and without the signet, get blockchain info. Yep, we are still on signet as it says up here, and we have all the blocks. Okay, good. So now we don't have to enter -signet on every command. Nice. Okay, so that's all for this part of the tutorial. Let's go to the next part, which is in Appendix A. In Appendix A, we will create a wallet, and we will fund the wallet, send money to it, and we will send money from it. And then I think we're done. The commands we're gonna do here are pretty hairy, some of them, but please try to follow along anyway. First of all, I will show you some nice things with both Bitcoin, with primarily Bitcoin-CLI. It has a help section, which is nice. So you can run Bitcoin-CLI help. And let's pipe it to less. Here you have all the commands that the full node can accept. For example, you have this get blockchain info, which is here. That's the one we already used, which will give you information about the blockchain. And you have several other commands here. I encourage you to explore them. And you have some control commands here, for example stop, that we already used. And then they are grouped by category, some network commands, transaction commands, and some wallet commands. And this is where we will work mostly today, with these wallet commands. For example, we will create a wallet pretty soon. And apart from this help, you also can get specific help for specific commands. For example, this create wallet. So you can do help create wallet like this. And this will give you help for how to create a wallet. So a create wallet command looks like this. First you write create wallet, then a wallet name, followed by a number of optional parameters or arguments. Okay, so I'm gonna go down a bit here. One difference from when I wrote this book up until now, when I wrote the book, the latest and greatest version of Bitcoin Core was 0.17. And things have happened a little bit since then. When you started Bitcoin Core 0.17, it would create a wallet for you automatically, a default wallet. But that wallet is unencrypted and it's not recommended for use. So now they have chosen to not create a wallet by default when you start Bitcoin Core. So we will have to create a wallet instead. Sorry, I'm gonna go back up here. Never mind. So we will have to create our own wallet here, and we will do that with create wallet. One moment. yeah, so we want to create a wallet. So we do it like this, create wallet, and we will add a wallet name, Grok, and we will say that we want, we don't disable private keys. No, we don't want to disable private keys, so we say false. This is the second argument here. And the third argument, whether we want to create a blank wallet with no keys at all in it. No, that's also false. And then we have this passphrase, which is used for encryption of the wallet. And it's going to be really silly here, XYZ987. That's the passphrase for this wallet. But the problem here with doing this, if we write the passphrase on the command line itself, it's gonna end up in the history of bash. So I'm gonna show you this. If I write echo hello 123, it's gonna print out hello 123 on the screen here. And if I now look at my command history, my 4 last commands, you can see my 4 last commands here. Among them are echo hello 123. And these commands, this history, is stored in a file on the file system, which is good and convenient, but when you write sensitive information on the command line, you don't want that sensitive information to end up in your bash history. So to avoid that from happening, I will add a space in the beginning of the command, and that signals to bash to not store this in the history. So that's what I do now. I added a space at the beginning here, and we have entered our passphrase, and then we have a few other optional, but we'll enter false, false, and we want this wallet to load on startup. So if you restart the node, you want this wallet to automatically load into the Bitcoin full node. If you don't have true here, you have to manually load it when you need it. Okay, so let's run this. And it takes a little while because it needs to create some randomness in order to create your private keys. So now it's ready. It has created the wallet named Grok. And we can do get wallet info. So we have this wallet called Grok, and it has a balance of 0 and an unconfirmed balance of 0 as well. I will talk a little more about those in a while. When we actually send coins, I will talk more about those. And what else is there to say here? You have this unlocked until, which means that when unlocked until is 0, it means that this wallet is now locked. No, you can't spend money from this wallet because the private keys are encrypted on disk. And in order to unlock this wallet, you need to give the passphrase, this passphrase up here, to the full node so that it can unlock the keys. Or decrypt the keys. Okay, we have created a wallet, but before we want to send funds to it, we want to back up this wallet. Because if you don't back up the wallet and you send money to it and then the computer breaks, the computer blows up, you will lose your money. There is no way to get them back. Once the private keys are destroyed, there's no way to get back your money. So it's very, very important that you always back up your Bitcoin wallets. No matter what wallet you use, you should always back it up. And in Bitcoin Core, you have a command named backup wallet, and we will run that backup wallet, and we will put the backup in grok.dat. Sorry, not .grok.dat, but in grok.dat. Okay, so now we have backed up the wallet. Let's have a look at it. We go to our home directory. Never mind, I'll just do this instead. So this is our backup file. We should take this backup, store it on a USB stick, and put it in a safe somewhere. This contains your private keys that you will need if your computer blows up. You only need to do this backup once. You don't have to do it after every transaction or so. Once is enough to regain access to your private keys to all your addresses. Okay, so we have now backed up the wallet, and we'll go back to the bin directory, and it's time for us to receive some money. And in order to receive money, we need a Bitcoin address, an address that you can give to the payer so that they can pay you. And we will do that now by using Bitcoin-CLI get new address. This is an improvement or a change since 0.17. I want a new address format that's called BEC32. I won't go into details on that, but if you want a new address format, if you used 0.17, you had to actually tell it that you wanted this new address format. But now it's the default format, so this is enough. Okay, so we have got a new address. This is our Bitcoin address. Since this is test Bitcoin, it's just fake Bitcoin. The addresses look a little bit different from mainnet Bitcoin addresses. It starts with TB1Q. All testnet or signet addresses will look like this. Start with these 4 characters, and then they will have a number of random looking characters after that. And if we use real Bitcoin addresses, it would be BC1Q instead of TB1Q. TB for test Bitcoin, BC for Bitcoin. Okay, so we have gotten this new address here. So it's time to go to another wallet and send money to this address. So I'm gonna open up another terminal here at the bottom. You don't have to pay much attention to how I do this. It's just another wallet. I will send Bitcoin to from that wallet to my wallet. And we're not this cheap. I want to send us 5 millibits. So the unit here is whole Bitcoins. So we will send 0.005 Bitcoins to this address here. Yep. Sorry, like that. Okay, so we have created a transaction with this transaction ID. And we will now look at our balance. Get balances. As you can see here, we have 3 different balances, which is weird. But first of all, we have 0.005 untrusted pending bitcoins. That's the one that we just sent here. And they are untrusted because they are not yet part of the Bitcoin blockchain. They are floating around in the Bitcoin network right now, waiting to get written into an actual block in the Bitcoin blockchain. And when that happens, those 5 millibits will be transferred, will actually disappear from this line and appear here instead. So right now we have 5 millibits, but they are not confirmed yet, as we say. And we can list transactions to see this incoming transaction here. List transactions, which is just another command that we send to Bitcoin Core full node. Yep, as you can see here, we have received 0.005 with no label, and it's not confirmed yet. Means it's not part of the Bitcoin blockchain yet. So this is our incoming payment, and it will take a little while until these coins are actually on the Bitcoin blockchain and we can trust them as ours. For example, if this was a trade, I was maybe selling a popcorn machine, I wouldn't hand the popcorn machine to the buyer until I actually see the money on the Bitcoin blockchain. Otherwise, if I don't do that, I am an easy target for scammers who want to double spend their money. So I can easily be scammed this way. If I give them the popcorn machine, he can run away with the popcorn machine and more or less undo this transaction. And I don't want that to happen, so I will wait until this transaction is confirmed. And while we do that, we can move on a bit to sending money. Actually, we can check right now if we have. No, it's still pending here. So eventually it will end up on the Bitcoin blockchain. But we will prepare now to actually send money from this wallet. While we wait for this, we will prepare to send money out of this wallet. And let's say that we want to send money to this wallet that we have right here, to this other wallet in this terminal. I'm gonna get a new address here. So this is the address we want to send money to. And I'm gonna prepare the command to send money, which is probably the hairiest command we're going to do today. Sorry, that's not it. That's not what I wanted to do right now. Sorry. Oh yeah, it is what I wanted to do. Sorry. Okay, so we will use I'm bringing up the help for send to address. And I'm temporarily hiding myself from this stream so that you can see my... No, I'm gonna move this window over here instead, of course, so that we see more of this window here. So send to address, it takes a number of positional arguments, an address, an amount, and a lot of other arguments. And we don't want to enter values for all the arguments, all the optional arguments that we are not interested in. We just want to go with the defaults for those arguments. So instead of using positional arguments like this, we're going to use named arguments. And you do that by adding -named at the beginning. As the first command line argument to Bitcoin-CLI, you add the -named. And then you enter the command, and then you add the name of the different arguments that you want to use. So in our case, we want to use the address argument, which is the address to send to. And we got the address here from the other wallet. We're adding that there. And we want to send 0.001 Bitcoin to that address. And we want to pay a fee of 1.3 Satoshis per byte, which Satoshis per byte is the more or less standard for how to measure the fee. The fees are measured in Satoshis per byte. You don't pay a fee as a percentage of the value of how much you send, but as a percent, more or less as a percentage of the number of bytes you send, because the number of bytes is what determines the cost for the Bitcoin network to process your transaction. So the fee rate is Satoshis per byte, and a Satoshi is 100 millionth of a Bitcoin. It's the smallest possible Bitcoin unit. So this is the command we want to run now, and it will fail because please enter the wallet passphrase with wallet passphrase first. So we will do that. And I'm going to move this back here, I think. And we can go to the tutorial page again in the book and have a look. We will... wallet passphrase is a way to is how you give your passphrase to Bitcoin Core, so that it can decrypt the private keys, so that it can sign the transaction that you are trying to create. So Bitcoin-CLI std in wallet passphrase. I will explain what this std in is. That's another way to enter sensitive information in Bitcoin Core. Instead of writing it on the command line itself, it will be expected as input from standard input when you have started the command. But let's start with the help section on the wallet passphrase. So it expects two arguments, a passphrase and a timeout, and both are required. So I will And I don't want to enter the passphrase on the command line itself because I don't want to enter sensitive information. Of course, I could do this trick where I add a space before the command, and but I want to show you another way to do this. It's called -stdin, which means that it's going to read the command line arguments from standard input instead of from the command line. So when I do it like this, it waits for my input. Now it wants the passphrase, which was XYZ987, and I hit enter. So now I enter the first command line arguments, which is the passphrase, and then it expects a timeout. And the timeout is the number of second Bitcoin Core will keep this passphrase in memory until it throws it out for security reasons. It doesn't want you to forget to, or rather, it doesn't want it shouldn't keep sensitive information forever in its memory. So that's why you add a timeout here. I add a timeout of 5 minutes, which is 300 seconds. And these are all the arguments that we want to give it. So we hit Control D here to signal that we are done with input. And now we have entered the wallet passphrase into Bitcoin Core's memory, and it's going to be there for 300 seconds, and then it's going to be locked again. So now we have more or less unlocked the wallet, and it's time to try to send money again. So we'll bring up this old command again, where we send money to another address. And this time it worked fine. The transaction was created, and we got this transaction ID. We can have a look at our balance again. It says here trusted is what we had before. We used to have 0.005 here, and now it's just shy of 0.004, which is 5 millibits minus 1 millibit that we just send, minus the little fee that we talked about earlier. And we can have a look at the other wallet, the receiving end of this transaction. Get balances. As you can see here, it has untrusted pending. It has 1 millibit incoming that it doesn't trust yet because it's not part of the Bitcoin blockchain yet, but it will be eventually. And it has some old coins here which are trusted. And as you can see here, we have 0 in our untrusted pending because we sent the money, so we trust ourselves, of course. So if we send money out, we trust that we actually did send money out, and we are not planning to double spend this money, of course. So we can trust this money to be ours. And I think that actually concludes this tutorial. We have created Bitcoin, we have downloaded and verified and installed a Bitcoin full node on a Linux command line machine. And we have created a wallet on that full node and sent money to it. And we have sent money out of that wallet as well. So I think that that's all. And I hope you enjoyed this little tutorial and that you found it useful. And I can't, yep, and there are no questions on the chat, so I think we'll just call it a day here. And thank you very much all for joining me today, and I enjoyed doing this session with you. Don't forget to check out the book at manning.com. You get 40% off if you use the code TWITROSE40, the one right here. Just use that one. And have a nice day or evening wherever you are.